Hi folks, this is a centripetal force problem, and here goes. A fly is sitting on a record that's going around in a circle on an old-fashioned record player. The fly is sitting 0.15 meters from the center of rotation. The period of rotation is 1.80 seconds, and I want to know what is the maximum coefficient of friction necessary to allow the fly to hold on to the record. So let's write down what we know. We know the period of rotation is 1.8 seconds. 1.80 seconds. We know the fly is 0.15 meters from the center, so that is his radius from the center of rotation. And I want to know coefficient of friction. Well, coefficient of friction, that goes back to the old friction force is mu over normal force, and I'm looking for mu, the coefficient of friction needed so that the fly can hang on to the record. If I'm going to involve forces and friction, that means I am going to have to draw some forces. So let's draw the forces on my fly. Force of gravity is down. What force is up? Yep, normal force. Now, what force keeps the fly moving in a circular motion? The centripetal force in this situation is friction force. When you're dealing with a centripetal force, there does not have to be a force in the opposite direction. Matter of fact, you must have a net force towards the center of the circle for rotational motion to occur. As always, we are going to sum the forces horizontally, and we are going to sum the forces vertically. In the vertical direction, up and down, the sum of the forces are going to be 0. The fly is not moving upward or accelerated downward. He's just sitting on that record. Horizontally, he's going in a circle, so he is accelerating in a centripetal manner. So the horizontal force is making the fly accelerate in a circle. Now we're going to create our equations. So horizontal force is my friction force. My friction force is going to make the mass of my fly centripetally accelerate, and my force normal is going to be equal to the force of gravity. Forces up are going to equal forces down. I'm going to replace friction force with mu times normal force. Mu times normal force is going to make my mass centripetally accelerate. And my normal force, I'm going to replace force of gravity with mass times acceleration of gravity. Now, the mass of the fly is not given. And so I'm going to get rid of mass, and I'm going to do that because mass times acceleration are going to replace normal force over here. Mu mass, acceleration of gravity, is going to make the mass of my fly centripetally accelerate. So those two go away. Mass is going to cancel, and I want mu. So mu, coefficient of friction, will be centripetal acceleration divided by gravity. Cool, but how do I find centripetal acceleration? I have two equations for centripetal acceleration. V squared over r, or 4 pi squared r over t squared. So let's go back and take a gander at our data and see what I've got. I've got radius, I've got period, so which one of these do you think I'm going to use? Yeah, this one. I don't have angular velocity or linear velocity. So mu is going to be, I'm going to replace this for centripetal acceleration, 4 pi squared r over t squared, and I still have acceleration of gravity down in the basement. Now let's throw our numbers in. 4 pi squared, radius of my circle is 0.15 meters. T, time to go around once, is 1.80 seconds. Got to square that. And then down here, acceleration of gravity, 9.8 meters per second per second. So my coefficient of friction when I do all of this, you know what? I got to do the math. 4 times pi squared times 0.15 equals. divided by 1.8 squared equals, divided by 9.8 equals, and I end up with 0.1865, and if I'm going to round this off to 3 sig figs, 0.187, and that's going to be my coefficient of friction. All right, see you next time.